Before we will start, Miss Magan, kindly lead a prayer. Let us have our attendance. So if I call your name, say present. Good morning, everyone. Praise be Jesus and Mary. Okay, so thank you. So before we will start with our new topic, let us first have a short review of what we discussed last meeting. Okay, so Miss Bakasnot, can you share with us what we discussed last meeting? Thank you for that, Miss Bakasnot. Okay, Justin, so what did you learn about our topic or our discussion last meeting? So before we will go to our new topic or our lesson, we will have a game. So this game is called Guess Me. So what you're going to do is that I already group you, and each group has 5 members. So you are going to have a video call in the message, and you are going to guess if that thing is similar or different. Okay, so I already sent to you the instructions on what you're going to do. And after 5 minutes, please go back to our meeting because we are going to check your answers. Okay, so send your answers now and please tell others to come back so that we are going to check your answers. This is the correct answer. Okay, so since we are done with our game, we are going to proceed now to our discussion. So, I will present to you a video. So, after watching the video, I want you to share what you understand about that video. Okay, so let us start. So, our topic for today is about set theory. So, we are going to watch a video, and then after watching the video, I will be asking you some questions, and I want you to share your understanding about that video. Okay, so let's start.
Friends, let's have a look at these images. What do you think about them? We have a bunch of keys, a school of fish, a group of letters, a pile of books, and a bunch of flowers. The one thing that can be seen in common is that everything is in the form of a group or set. And well, that's our topic for today. Sets. But what exactly is a set? A set can be formed of anything that can be well defined or distinct. Now, let's see what do we mean by well defined or distinct. Let's take an example. A set of numbers from 1 to 10. Now, this is well defined. You can list all these numbers also, right? So, this can be a set. Let's consider another example. A set of smart students or a set of generous people. Can this be considered as a set? No, not exactly, right? Because here, smart or generous cannot be defined or measured, or we can say that these are relative terms because the meaning of these words will change from individual to individual. Hence, we cannot make a set of these situations. Let's take a simpler example. A set of all the letters that comes after T. So what all letters will be there? U, V, W, X, Y, and Z. Yes, so this can be also called as a set, right? Let's see a few of these examples if we can form a set of them or not. The first is states of India. So, can we form a set of this? Yes, because there are 29 states in India and you can list all of them. The second one is strong students in a class. Well, this cannot be a set because strong is a relative term. But suppose here if I'll add a condition like students who weigh more than 50 kg in a class are to be considered as strong. Can now this be formed a set? Yes, because now we have a number, a quantity or a well-defined and distinct property that we can use and form this set. Right? Let's see the next one. Students who have scored 70% and above in the last semester? Yes, you can form a set of this. Collection of great people in the world. Again, great is a relative term and we cannot form a set of this. So I hope by now you know what are sets and in which conditions we can form a set and cannot form a set. Let's move to the next step. So how do we present these sets? There are two different ways to write these sets. One is listing method or also known as roster method. The second is rule method or known as set builder method. Let's see what listing or roster method is. If I want a set of all letters in the word mathematics, then how will I write it? Well, this is a very simple method. Let's look at this in a little more detail. All the letters in the brace or curly brackets are known as elements. A or any letter can be used to represent this set. However, there's one tiny mistake that is there in this set. The elements in this set are never repeated. Every element appears just once in a set. Hence, the solution of this set of all the letters in the word mathematics will be A is equal to curly brackets M A T H E I C S curly brackets closed. This is how we present a set in a roster method or a listing method. Now since just we have listed all the letters is the reason why it is known as a listing method. Next can be a set of all the days in a week, a set of all the rainbow colors, etc. We have also been studying sets in few of our previous grades. It's just that we never knew that they are sets, like a set of natural numbers, a set of whole numbers, a set of integers, etc. Sets are used in a variety of places in mathematics, but we'll see that in the future sessions. So now I believe you can make any set using the listing method. Now what happens if I ask you to form a set of all the whole numbers between 0 to 10,000? Can we use this listing or roster method to list all these whole numbers till 10,000? No, right? Hence, we have this rule method or set builder method. Now since we are building a particular set, instead of writing all the elements in the set, this is known as a set builder method. Now a set using set builder method is written like this and is read as A is a set of all x such that x belongs to whole numbers and x is a whole number between 0 to 10,000. Now, was this a little difficult? Let's try another set. Now, can we represent the set of all letters in a word mathematics in the form of a set builder form? Well, yes. Let's name this set as B. B is a set of all x such that x is the letter of the word mathematics. Every set can be represented in the set builder form. Try a few of these sets in the form of listing as well as set builder method. Now, why this method is known as a rule method? Now here we can see that we have added certain conditions in this set. This is the reason why this is also known as a rule method. So till now we have seen that what is a set? things that can form a set, and ways to represent these sets. In our coming sessions, we will see what are the different type of sets and also about the Venn diagrams. I hope this session was useful to you. If you have liked this session, please hit the like button. Do comment down your queries and don't forget to subscribe our channel.
Okay, so let me ask you a question. So what is set? How about what are the two ways to represent a set? Okay, so let's watch another video. So this video is about the types of sets. So please watch it carefully because I will going to ask some question again.
Hi there. Now in this video what I want to do is talk to you about the different types of sets that you're likely to meet. And first of all, the first type of set is a finite set. This is a set where the last member is known. So for example, with this set here, the last member is 10. It's got a finite number of members in it. So the next type of set has to be an infinite set, and this is where the last member cannot be found. So for example, this could be the set of integers 1, 2, 3, 4, 5 and so on. There's no end to this set. Now another set you're going to meet quite often is the empty set, and this is a set that has no members, and the empty set is written as two curly brackets here with nothing written inside it, or you could write it as a circle with a line through it. So what we've got here is the number of elements or members in the empty set is going to be 0. And it's important to note that if you have a set with the element 0 in it, it's not empty because the number of elements in it is 1. That element is 0 itself. So don't be tempted to make that mistake. Now another type of set that you're going to meet is a subset. This is a set within a set. For example, if you had the set P, which was the integers 1, 2, 3, 4, 5 and 6, then a subset of P could be, say, the set Q, which has the members 1, 2, 4 and 6. These elements are contained within the set P. Or you could have another subset, R, which is just two elements, 2 and 4. They're contained within the set P. And note too that R is a subset of Q. You can see that we've got these two elements, 2 and 4, within set Q. Now we use this notation that you see here, which illustrates a subset. We say that Q is a subset of P, and R is a subset of P. And also we've just seen that R is a subset of Q. So when you see this symbol, it's read as Q is a subset of P, or Q is contained in P. Now if you reverse the symbol round, then it's read that P contains Q. Now I don't find that I often see this, but just in case you do, then that's an explanation of that particular symbol. And finally, the last set that I want to talk about is the universal set. And this is a set of all members under discussion. You'll come across this a lot when we talk about Venn diagrams in later videos. And the symbol we use for the universal set generally is a U, or you might see this squiggly sign here. And it's used then to denote the universal set. So let's suppose that U was the set of integers from 1 to 10 inclusive. Now very briefly, I want to introduce you to Venn diagrams. I'll be looking at going over these in greater detail in later videos, but a Venn diagram is a pictorial way of showing the relationship between sets. And with Venn diagrams, we take the universal set. And if we take this as an example, the integers from 1 to 10, what we do is construct a rectangle to house all those elements. In this case, from 1 to 10. And so if I complete the rectangle there, I prefer to draw the U for the universal sign rather than this squiggly symbol here. So if I restrict all the elements as being the integers from 1 to 10, and suppose I look at this set P with the integers 1 to 6, this is a subset of the universal set. It's contained within it. And what we can do then is just draw P, any shape we like within the set U. I'm just going to draw a curve, something like that, and I'll label that P. Now, the set Q, for instance, is also within P. It's a subset of P. So if I wanted to show that relationship, I could just draw a curve, anything I like, within the set P, and I'll just label that one Q. And similarly, I could draw the set R within the set Q because it's a subset. I'll leave it out for now because I haven't really got much space. And what we do now is to put our values in, our elements in. So for Q, I've got 1, 2, 4 and 6. I start from the inside here and put 1, 2, 4 and 6 in. And then the remaining elements from P, that will be the 3 and the 5. Okay, so I would put the 3 and the 5 in some space on the outside here. So let's just put the 3 there and the 5 there. So I've got in P, I've got 1, 2, 4, 6 and the 3 and the 5. And in this space outside of P, I put the remaining elements that have been left out of the universal set U. So those elements are going to be the 7, 8, 9 and 10. So I just find any space I like. There's the 7, 8, 9 there and 10. And so what we've got here then is a typical Venn diagram, which, as I say, shows the relationship between the sets. But I'll be talking more about that later on. So I hope that's given you some idea anyway on the types of sets that you can get, the symbols used and how we can denote that relationship in a Venn diagram.
Okay, so this is our last video. Please watch it carefully so that you will know how to use a Venn diagram. And then after that, we will have our activity and our quiz.
We saw the Venn diagram of two sets in the previous video. Set of people who like soccer, A, D and G, and a set of people who like cricket, B, C, D and G. Looking at these sets, could you write the set of people who like soccer or cricket? This means that we have been asked for the set of people who like at least one of these sports. We have to find S union C, which actually means S or C or both. A, D and G like soccer. Looking at the cricket set, D and G already like soccer and have been included. B has to be written since it hasn't been included yet. And so does C. This is the set of people who like soccer or cricket. And what is the set of people who like soccer and cricket? We have to find S intersection C, which is the set of people who like both soccer and cricket. There are just two such people who like both the sports, D and G. But we have already seen all this before. How is the Venn diagram helping us? Let's zoom out and look at the beauty of Venn diagrams. This is set S with A, D and G, and this is set C with D, G, B and C. We can see that D and G are common to both the sets. So let's move set C to the left such that they overlap. They overlap since they have a few elements common to each of them. And yes, they are called overlapping sets. Now we need to see how it helps us find S union C. It's simple. You just write all the elements you see here: A, D, G, B and C. That's the advantage of using Venn diagrams well. It directly gives us a representation of all the elements in consideration. And what about S intersection C? This is much simpler. We just write the elements in the overlapping region, D and G. This means that once we draw the Venn diagrams correctly, union and intersection can be found out within a few seconds.
Okay, so for your activity, you are going to use a Google Docs application. So last meeting, I already told you to download this app and then sign up or log in because we are going to use this application. So I am going to show you how to use this application and how you are going to invite your group mates in here. So watch this. This is how you are going to use. So go to your Google Docs, click this plus sign so that you will or you are going to create a new document. Yes, then tap this new document. For you to add your group mates, click this and then type his or her email, for example. Okay, so I am to add your group, click this one. So he or she will be notified that you invited her to the Google Docs. Okay, so that's all. And then for you to create your activity, just click this one and then you can type your answers here. So that's all. Pass now your activity. So for your quiz, I will post it in the Google Classroom and also your assignments. So please pass it on time. So I guess that's all for today. Goodbye and thank you everyone.